Hello, good afternoon. Welcome to OCP's afternoon executive session. My name is Mohan Kumar. I'm a fellow at Intel, and Intel is the only place I know, so I have no reference point. I worked here since I graduated for the last 25 years. Today I'm going to talk to you about the innovations that Intel is bringing into the cloud. So one of the reasons I'm talking to you about cloud is that I'm also the director of cloud architecture in Intel's data center group. So I'd like to talk to you about some of the innovations that Intel is bringing into the cloud here. So I'm going to just give you an overview and then talk to you about some specifics, innovations we're bringing in and what they mean to OCP and to the cloud, and summarize at the end. Before we get into the meat of the presentation, I just wanted to give you an overview of the cloud continuing to grow. So these are some stats. This is by the year 2021, a couple of years away. Digital retail, which is, it's starting to emerge. It's going to grow into almost a $5 trillion business. Digital advertising is growing to $400 billion. Digital video and media, another $120 billion, and cloud services is $300 million. And it's easy to believe this numbers, right? Cloud is an integral part of our lives, right? I bought a car recently. It came with an app that talks to the cloud, updates itself. I bought a speaker. The speaker comes with an app that talks to the cloud. I don't know why, but so the prediction, the projected growth of capacity that's needed in a cloud environment is going to double in the next 4 years, right? But at the same time, the power and thermal constraints continue to remain, right? Because you can only build infrastructure this fast and no faster, and then the ability to provide for that electricity and all that stuff is very constrained. So what do you do is a big challenge as this type of growth happens, right? So it's kind of driving a need for high density in the environment, right? But before we start talking about those things, OCP's origins were in the platform space originally, right? But then cloud doesn't worry about just hardware, but we need solutions. So hardware, which is meaning platform, whether it's storage, compute storage or networking, is only one element of it, right? And then you need to essentially secure your platform, right? And this is becoming especially more relevant when many of the components that are inside your data center or your data center platform have a controller that runs a firmware on top of it, right? Now we need to make sure those things came from who they say they came from. Otherwise, you have vulnerable to problems. And then these firmware components, the fact that they exist means you have to maintain them, update them, maintain a fleet hygiene, right? And that in itself poses another problem, right? And then you have to manage all these infrastructure. How do you manage them at scale? And the problems of so like typical tier 1 data center could be, if you put it all together, it could be in the 100 to 200,000 servers at times. And every simple problem, turns into a bigger problem when you apply that at scale magnification to the cloud, right? Even simple thing like setup, like you set up the typical platform, even your laptop that I'm presenting from has a setup screen that's invoked by me pushing a button when you're in the boot cycle. How do you do that with 100,000 servers? You can't, right? So there is different type of management solutions that needs to come into play here. And now you can't just manage, because there are hundreds of thousands of servers, you can't just talk about server management. You have to talk about rack and how do you bring power and how do you bring cooling at that level also. And then you have to worry about data center because there are equipment that's feeding that power and that cooling into your racks or servers in your data center. And they don't talk to each other, and because they all are on different protocols and so on. And all of this needs to be solved. When you do all this whole thing, then this becomes a cloud data center solution stack. So let's see how, if you map it to the OCP projects, let's see how this taps out, right? So for server storage and networking, there are projects that are underway that track to it. And this, like I said, was the origins of OCP. Since then, now platform security is being handled by the security project that was kicked off last year, I believe. And then same again, last year we kicked off open system firmware. And that's looking into how do you do firmware at scale, and how do you update, and so on. I'll talk to you a little bit more about that. And there is a project to do hardware management at the platform level, right? And then there is another project to look at rack and power. And there is also one that looks at a data center facility level. And this is where you talk about, like some heavy equipment that's supplying megawatts of power into your environment and how that megawatt translates to kilowatts to watts in your eventual silicon. And how do you cool that, right? All the ambient, everything, that's part of the data center facility. So overall, I think, I'm very glad to see the focus shift from hardware to solutions, because that's where we need to be effective for us in the cloud. So that's a very good trend to see. So I want to now take each one of those big pillars we talked about, and I don't have the time in the 25 minutes that I'm given to cover all of them, but I'm going to pick some of those things. And the one big thing in the server world is, our focus has been traditionally on one socket and two socket servers. And this is not even a surprise, because if you go back and look at all the contributions and all the platforms folks have talked about the last 7 or 8 years of the existence of OCP, they're all about one socket and two socket platforms. That focus is shifting. And I went through some of the data points on how cloud is growing, and how we are pressured, so that high density is causing some of this focus from 4-socket to 8-socket. The other reasons are folks want to have a larger memory footprint, and they want to attach lots of IOs. So all of a sudden now you find yourself, you probably attended the keynote session, you saw the 8-socket platforms being talked about, which you would have never imagined only a few years ago that we'll be here talking about 8-socket platforms. So, or 4-socket platform for that matter. So the 4-socket, the other reason for going down the 4-socket path is high density. So at Intel, we've been looking at developing reference designs for cloud optimized platforms. And the goal is, how do we do the maximum number of core count for these? When you say cloud optimized, you're taking these and provisioning VMs and containers and functions on top of them. How do you do that in the footprint that you've been given, right? So you essentially go for the density. So then I need to have a lot of core count. How do you do that in, like, for example, in a 2U, which is a typical form factor, or I should say 2OU, now that I'm at OCP, because OCP has its own rack unit form factor, as you know. So in order to do this, you need to essentially provide a solution that's high core count and optimized for providing a VM IaaS, which is infrastructure as a service, which is a VM density, how many number of VMs, provide them the serviceability options in terms of the number of drives, the networking, right? So as you increase your core count, you have to also increase your networking bandwidth that's coming in. Typically, if you look at public cloud is provisioned anywhere from gigabit, excuse me, to half a gigabit per VM, essentially, that's coming into the platform. And you typically put 2 VMs based on the threading model. So if you have 100 cores, you're looking at 200 VMs, and you do the math on how much networking that needs to be supplied. So again, so you're looking at OCP 2.0 or a 3.2 type network module plugging in. And given that this is focused on cloud, you want the serviceability, so you don't want all the drives to be front accessible. So we developed a whole reference design on the basis of this. And you don't have to take just the Intel's word for it. We actually worked with Tencent, who's one of the leading cloud service providers in the world. If you've ever been to China, you can be without your passport, but you can't be without your WeChat, right? It's that important part of their daily life there. So we worked in close collaboration with them to validate these principles. And so today, we work with a number of vendors, but as you can see from all the logos at the bottom, but we are very pleased to announce today, in partnership with Inspur, we are contributing the very first cloud-optimized 4-socket platform to OCP. I don't know if the Inspur folks are in the room here somewhere. Where are you guys? Kevin is here, and you can take the message back to Inspur there. So what's in the platform, right? As you can see from the graphics, it's you can see the 4 sockets, and you can also see the front end with drives. It fits in a specific form factor. It's 450 by 780. Yeah, the board is designed to fit well within the typical cloud usage envelope. It uses the 6000 series Xeon processors, and we said, we have a lot of cores and a lot of VMs, which means you need to have a lot of memory and a lot of I/O to go along with it. So we have 48 DRAM channels on the DIMM slots, on this platform, and up to 1.5 terabytes of memory capacity. You have 10 drives in the front, and you have option for PCIe cards in the back, in addition to an OCP 2.0 or a 3.0 NIC as well. And this platform is available today, so you can actually actually go see this platform at the Inspire booth. And we also have a lot more detailed discussion on the usage models and so on at 3:15. Myself and my colleague from Inspire will be talking about it there. And I checked. I don't know how the process and submission works. I checked. I can't find my own submission, so I'm sure there is a latency. But you should be able to find it. In here, it's the code name is Crane Mountain. That's what it will say when you see it. It'll say Intel say high density cloud optimized platform, and it'll say Crane Mountain as well when you see the contribution. So that's on the platform, but managing something at scale, all these platforms with their servers and storage and networking and so on, comes with lots of interesting things. So when you have a solution like this, you have bound to have hardware and software errors that you have to deal with, just as a natural progression of just ambient, right? Particle strike. Your memory has a single bit error, and you have to deal with those realities. And then you have to update your software, you have to update your firmware, and then the at-scale magnification I talked about earlier, right? Everything that may be trivial turns into a big problem when you're dealing with 100,000, 200,000 in a fleet, and you have to do something to that. And if you can't do them well, you're ending up in a place where you have service outages. And the outage is not like whatever I'm sure you read in the paper today, right? It's not a catastrophic outage right? But the fact that you have to take stuff out offline to apply a firmware update, that needs months and months of planning to make sure that you don't have the kind of stuff that you read today, right? That's really the key reason for us being able to manage. So to this end, at Intel, we are working on what's called the seamless firmware update solution. But one of the solutions here is the ability to do modular and secure firmware updates, right? So anything that has got hardware like a CPU, BMC, your NIC, storage, all of them have a firmware associated with it, right? And that firmware needs to be updated, and just to keep the fleet. You have an issue with a security issue, you have a power issue, a performance issue, or you're adding features. Any number of reasons could be causing you to update these things. Now, what we have is a monolithic update model. And by the way, these type of updates have become a reality even in the consumer life. I'm sure your phone tells you need to update to iPhone version 10 right now, or whatever it is, right? And the problem with this, the problem is not with the updates, and the problem is what the update causes, right? When it's my phone or my car, updating it, it's one individual device that's doing it, and you're done. When I scale it to 100,000, now 100,000, I don't know how to do it without taking. I can't just say shut down all 100,000 and I'm going to bring it back in 3 minutes, right? You have to essentially be able to do them in a more modular way than this all or nothing model, because any firmware update that turns into I'm going to stop the system is not a good firmware update. So what we're doing is working with the Open System Firmware Work Group to come up with a model that essentially does the firmware update solution in a modular fashion, so you don't have to go all or nothing. If you're updating only a portion of some specific code, you don't have to update the entire firmware. So that modularity, not only we would like to have that for ourselves, but we want to work with the community to make that be a broad capability that exists in this environment. So You would hear a lot more about it in detail in the session tomorrow at 3:30. Samuel will do that session with our partner from Microsoft. So the other pain point, if you will, I mean, again, innovation comes from somebody feeling the pain on something, right? The other pain points, I apologize for the eye chart in there, but I'll just tell you what happens. There is a mode called SMM. It's for system management mode. It was invented in the Intel 386. And the goal of inventing that was to provide battery management at that time for those emerging laptops of those days. And it has now become the de facto way for people to have a platform abstraction layer. Because software people like the OS, and they don't want to carry a platform-specific driver along with the OS at every time. So they use this mechanism in ACPI that traps into this SMI, and everything happens behind your back in the SMI, right? The bigger problem from a firmware updatability standpoint is that it's a transparent, it's an opaque firmware, right? You have no visibility into what it's doing. You have no way to audit it. And when you have to apply a change to it, you have to reset the system. Basically, you have to stop the system, update your BIOS or whatever, and bring it back. And this is not the way to scale to 100,000. So what we're doing again is working with the open system firmware community to come up with this new mechanism called platform runtime mechanism, which allows you basically for the platform to carry the same concept of, I wouldn't call it firmware, but it's somewhere between a firmware and a driver that then gets used by the OS. And now the OS can put it inside a container and essentially audit it. And most importantly, you can update this independent of having to touch the platform, which gives you the platform-specific behavior you want without all the pain of what it causes to the cloud in this world. And again, I'm just touching on it because I'm very conscious of me running out of time in 6 minutes here. But we have a session tomorrow bright and early at 8:30 that would talk about this in great detail. And I believe we have a demo in our booth. It's a video demo that shows what happens with and without this technology. And once again, we know that this is not specific to our platform only, so we're essentially broadly enabling everyone to take advantage of this capability. So I also talked about the fact that in order for a solution, you need to tap into things beyond servers and storage and networking. So one of the interesting things is that what the graph is showing is that the dotted line that's shooting up is where the power consumption should be if we had stayed on the trend that we were on at 2010, right? It would have been untenable in terms of the amount of electricity that you're consuming for a data center for a cloud data center type application. Instead, everything flattened out, and part of the flattening out is because you can't. These infrastructures are constrained. You can't just go from 10 megawatt to 20 megawatt overnight. Now, as we had more and more powerful processors and more capacity of memory and more storage, higher density, where do we go, right? If you cannot go up on the power chart, then we need to come up with a way to figure out how to optimize the existing power. And this one is essentially on the cooling. So cooling in a typical cloud data center is 15% of the total cost that they spend. The TCO graph, 15% of it is cooling, right? So today, one way to mitigate the power thing is to actually by mitigating the cooling, right? And the way you mitigate the cooling is essentially today it's reactive. It says this rack or this row is increasing in power. Send more cooling, and so it's causing more thermal, so send more cooling to this. That's the reactive loop that the data centers have today. So what we are proposing is to essentially do a proactive loop because many of these things are runs on patterns, right? Like if you look at a search workload, US comes online at 8 o'clock, goes offline maybe at 10 o'clock at night. There are patterns to your workload behavior, and there are patterns to your power in your data center if you're serving those type of applications. Like right? If you're using social media, I mean, you're not using any of these when you're sleeping, so I hope not, right? So you can use those patterns and essentially do a better job of pulling in the same cooling. So you're not, otherwise what happens is you overshoot or undershoot your cooling needs. And the idea is to be able to do to be exactly where you need to be. So you're spending just what you need and no more on your cooling needs, and therefore you're bringing down the overall cost of the data center. And again, I won't be able to do justice to it in 3 minutes, but there is a session tomorrow at 2:30 that we will talk a lot more details on this one as well. So, the general theme here is that we are trying to advance and bring cloud innovations through OCP projects, be it the high density platform, which we're really excited about, and we appreciate the partnership with Inspur and appreciate OCP's support for our contribution here. Or predicting the data center power, which we plan to contribute as a white paper, and we're also going to plan to contribute the Redfish profile to the data center DCF project. And other work that we're doing in partnership with OSF on the platform runtime mechanism. And there is one I didn't have time to talk about, which is on multi-socket FSB, which allows for, this is in partnership with Facebook to do multi-socket firmware support package boot. Because one of the things that needs to change in the way you, with server platforms boot, if you're going to have your own root of trust, is to have a mechanism where you have third-party code that's essentially in charge of the reset vector. And there are solutions for one socket, but our goal is to extend that to multi-socket with the work that we're going to talk to you about tomorrow. And we're also working on storage disaggregation. Individual drives in servers, especially in the one socket and the two socket world, end up stranding your capacity, right? You're not able to fully utilize the storage, especially as you see storage going to terabytes, and there are even 8 terabyte drives talked about these days. So, but then why don't we disaggregate? Most people don't disaggregate because they don't know if they'll get the same performance, right? And we are working on it. We're actually working on a tested configuration that shows you that you can actually get pretty much the same performance using NVMe or Fabric, and that too, it's TCP/IP based for the NAND type devices. So my call to action from all of you is that take advantage of the platforms and the solutions that we are contributing to OCP. Come partner with us on these solutions. I'm sure you have your individual area of expertise that we don't have, so we would love to work with each and every one of you to enhance our solutions. And we have some of these innovations that we could talk to you in a greater detail in a working session like we have tomorrow or at the Intel booth. And we welcome you to come visit us and learn more about it. And with that, I want to leave you with the list of sessions that are going to be from Intel tomorrow. And I'm sure I didn't cover all of it because there are so many sessions there. But these are some of the relevant sessions to what I talked about here today. And I hope you'll come visit with us. And I'll be here. And if you want to talk further or discuss, I'm happy to take any of your questions as well. Thank you for your time. I appreciate it.